Alumni and friends of the Eberly College of Science, thank you for joining us this evening and welcome to the Eberly Forum. This evening, John Asbury, a professor in our chemistry department, will take us on a virtual tour of his lab. During the virtual tour, graduate and postdoctoral researchers will demonstrate various experiments investigating the optical and electronic properties of photovoltaic and photocatalytic materials using the synthesis, spectroscopy, and laser instrumentation in the lab. And following this virtual tour, we will hold a Q&A with the science students who will discuss how they are participating in labs during the COVID-19 pandemic. I guess I should introduce myself as well. I'm Tracy Lankilder. I am the new Dean of the Eberly College of Science starting in October, and I've really enjoyed getting to learn more about our departments, including chemistry. So in addition to serving as a Penn State professor, John Asbury, whose lab tour we're going to get, is also a co-founder and chief science officer of Magnitude Instruments. John came to Penn State in 2005 after postdoctoral work at Stanford University, where he developed two-dimensional infrared spectroscopy as an approach to examine hydrogen bond dynamics in liquid water. And this led to new understanding of fast dynamics and energy relaxation processes in aqueous environments. In his work at Emory University, he reported the first measurements of the competition between hot excited state electron transfer versus electronic and vibrational cooling of excited molecules adsorbed to metal oxide semiconductors used in dye-sensitized solar cells and photoelectrochemical cells. And this led to new insight about the primary events leading to charge transfer in these systems. Since joining us at Penn State, John's research has focused on understanding how the structure and dynamics of materials and catalysts influence their applications in energy and material science. John, we are eager to see your virtual tour.
Thank you, Tracy. I really appreciate that introduction. And it's a real pleasure to get to be with everyone tonight and to kind of showcase some of the stuff happening in the chemistry department in my labs. I'm going to share my screen in just a bit, and I'd like to kind of give you sort of a walking tour of what the group does and why we do it. And then we'll zoom in to the students and I can talk to you about what they're doing and this kind of thing. So I'm going to go ahead and share my screen. And let's see. Let me do this. Yeah. So this is just sort of the opening slide, but what I wanted to do is kind of give you just a little overview of sort of, what we do and why we do it. So, we're as Tracy said, in the chemistry department, we would call ourselves physical chemists. So we kind of bridge the gap, if you will, between chemistry and physics. We're interested in understanding why materials behave the way they do. We have a particular focus on energy materials and catalysis, and I realized when I kind of look back on why that is, I was sort of motivated to go into science in the first place from my grandpa. He was back in 1941. He was a third-year graduate student at the University of Washington, and he was studying the gaseous diffusion of uranium hexafluoride. And so when the Manhattan Project started, he was in one of the most unique places to really understand that process and figure out how to scale it up at a level that had never been done before. And so he got involved in the Manhattan Project. I'm seeing something in the chat. I want to make sure I'm not. Oh, okay, right. And so when my mom and uncles were growing up, he couldn't say anything about what he did because it was all secret. But by the time I came around, he could, and so I got to talk with him and was really inspired to go into science. And he was a physical chemist working at the sort of the state of the art of his field, and I'm not sure I'm at the state of the art of my field, but I'm a physical chemist following in his footsteps. And I really enjoy that connection and realize that's been informed really all of the projects that we work on. We just sort of are working on things related to energy. And so we're going to begin, the tour will begin with a project that's funded by the Department of Energy, and also we have some graduate research fellowship support focused on photocatalysis, which is a systems that can absorb light from the sun and use the energy to store, it'll convert the energy into storing it in chemical bonds, basically making solar fuels, a type of artificial photosynthesis, if you will. We'll then move to a project that's funded by the Office of Naval Research through something called the Center for Self-Assembled Organic Electronics. This is a multi-university research initiative, or a MURI, that funds a group of faculty here at Penn State as well as at Stanford. And the Navy's interest is both fundamental as well as to develop means of having lightweight and flexible photovoltaics for mostly for Marines and their forward operating positions. They need to be able to make power and do it quietly. Photovoltaics are a great way to do that. And so organic electronics are a way to make them lightweight and flexible. We'll then move to our electrocatalysis project, which is supported by the National Science Foundation. There we'll meet some students who are using, combining, excuse me, electrochemistry, the ability to use electrical energy and convert it into chemical bonds. And we're studying the types of chemical processes that govern the efficiency and the rates of those. And we're using spectroscopy to tell us what the molecules are that are involved in those reactions. And finally, we'll look at an instrument that's being built in the basement of the Millennium Science Complex. This is a space where all those advanced electron microscopes are. We have a little corner of that. We're developing an ultrafast transient absorption microscope with support from the National Science Foundation as well. And that is to develop two-dimensional materials. So as we start the tour, we'll go in that order, and I'll just sort of introduce the students and kind of what they're doing and give you a little sense for how it connects to the projects that I just described. So at this point, I think I'm going to stop sharing my screen. And Nate, are you ready to play the video and I can talk over it? Is that right?
Yeah. Yep.
Great, great. Okay, so I'll stop sharing. All right. So hopefully you can hear me as I'm talking. So again, this is a real pleasure to be a part of the forum. Thank you, Tracy. Pleasure to be a part of the forum. As we break to the first student, this is Nicole. She's a second-year graduate student in the group, and she is working on that photocatalysis project where she's making we call them nanocrystals, but they're just small little oh, sorry, I get distracted by the chat. Little nanocrystals that have high surface area, and they're perfect for absorbing light and then having that energy close by to then drive electron transfer reactions or to change chemical bonding patterns. And so she's making, she's setting up now a synthesis. And we're actually going to get to see a little bit of that synthesis in action, because the nanocrystals emit light when they're excited in the ultraviolet. And so we'll get to see a little bit of that. But she's setting up this little apparatus, and she has to control the atmosphere, get rid of oxygen, get rid of water. You saw her pulling some glassware out of the oven that gets rid of the water for us. And she's going to be making nanocrystals called cesium lead bromide. And this is a model system. We don't really like lead that much, but it helps us understand how these systems work, so we can identify ways of getting rid of that lead later on. So she's about to, excuse me, she's about to finish it. the assembly and get the nitrogen flowing. Now she's ready. She's going to insert the reagents to start the reaction. And as it goes, Nate did a really nice job of capturing this. We have a ultraviolet light here on the left. You can sort of see that box that just fell. And it's exciting the nanocrystals that are forming in the solution. And you can start to see a green color that's forming there. It's really nice and strong now. And those nanocrystals have formed, and when they emit light, what that tells us is that they have a really nice electronic property, so they can really hold on to that solar energy that they'll eventually be absorbing, and hold on to it long enough to drive a catalytic reaction. Now, this is Kelsey, who's also on the photocatalysis project, and she has a sample that she's made, which is actually on a glass slide sitting in a solution, and she's shining light on it, and it's actually making hydrogen. It's a little hard to see in that video, but that was a photocatalytic process happening there. And here are a selection of some of the nanocrystals that Nicole and Kelsey have made on this project. I should note, Kelsey is a fifth-year graduate student, so she's going to be finishing up pretty soon. She's actually interested in teaching at the college level after she finishes up. This is one of the workstations that the students use. Now we're going to switch gears. That was the photocatalysis project. So we're going to switch gears now to the organic photovoltaic. So this is a project that was funded by the Navy for those flexible solar cells. And here's John. He'll be one of our panelists talking about working in the labs during COVID. But he's inspecting one of his samples that he's going to measure. And he's standing at an instrument. If it were purchased commercially, it would be called an Inspire, but it's a prototype for one of the instruments that my company, Magnitude Instruments, sells. And we, of course, developed them in my lab, and then we commercialized that. So he's now going to take one of those samples and mount it into, we call it a cryostat, because it allows us to control the temperature. And then we'll see him insert that cryostat after he's mounted the sample. He'll insert that cryostat into a shroud that allows him to control the atmosphere, or even to draw a vacuum around the sample. And then we do a lot of temperature studies just to allow us to understand what's happening at a detailed level. So he's mounting the sample. And what he's going to be doing here is exciting this is a photovoltaic film, that little blue film you saw on that window. He's going to mount it. I mean, he's going to excite it with a visible light that's going to sort of simulate the sun. And he's going to probe the generation of the sort of release of electrons in the material, that if it was in a full device, they would be flowing and making current. He's going to study the lifetime, how long those carriers remain available to be mobile, using this green laser that you see in the video now. And what he's going to follow is the time trace of their lifetime. And then we use that as feedback to our collaborators to develop higher performing materials. This is Ua, she goes by Yo-Yo in the group. And she is also working on the organic photovoltaics project. She has a different polymer, organic photovoltaic material that she is working with, that we get from our collaborators. And she's also inserting it into the transient absorption spectrometer, the same one that John was standing at. And Yo-Yo has been measuring a series of materials where we're trying to identify components of that photovoltaic material that will allow them to be more robust, to be more as well as more efficient. All right. This is a little snapshot of what the day kind of day-to-day experiments look like, and some views. We use this is an instrument that measures in the infrared, and so what you saw there was a little liquid nitrogen being poured into a detector to get it cold enough to measure that. Now we're going to switch gears to another project. This is the electrocatalysis project. And this is Jianing. He is a third-year graduate student in the group, and he's assembling the electrochemical cell. And this cell, so that will allow us to run a reaction. The catalyst is actually sitting on top of a silicon prism. We call it a waveguide because we can shine infrared light in on one side of the prism, and it sort of bounces up and down, back and forth between the two faces of the prism, reaches the other side, and it allows us to use infrared spectroscopy to measure the vibrational motions of molecules. And we can use that to sort of take snapshots of what the chemical intermediates are as the electrocatalytic reaction is occurring. We do this project in collaboration with Ray Schock, who's also a chemistry professor here at Penn State, as one of the, really does some very sophisticated nanocrystal research and novel catalysts. And so we're working closely with his group to examine the sort of the function and stability and efficiency of them. Here we have Jerry. He is a second-year graduate student in the group. We'll see him connecting electrodes to that electrochemical cell, and it's mounted next to it an infrared spectrometer, which is what we use to measure those vibrational features of the intermediates in the catalytic reaction. So he's got a number of things to connect. He has several electrodes to drive electrocatalysis, as well as to monitor them. The last one is called a reference electrode. He's just filled the reservoir with the electrolyte, and now he's going to bring down the electrodes that connect to the potentiostat that controls the current and the voltage applied to the cell. Here's a close-up of it. You can see the different electrodes. The reference electrode is the one the red clip is currently attached to. And the counter electrode is the one that's black that he's attaching to now, and so on. In these typical reactions we would study, he's setting up one for the hydrogen evolution reaction. We'd also look at the CO2 reduction, as well as the nitrogen reduction reactions. And now we switched to the last lab. So those are all were in chemistry. Now we've moved to the Millennium Science Complex, and we're following Kyle Munson, who is a postdoc in the group now. And he is building this transient absorption microscope that we're going to use it to control and ultimately study and eventually learn how to control the electronic properties of two-dimensional materials. And these are sort of atomically thin electronic materials that are really exciting for sort of next generation electronics, sensors, sort of the material beyond silicon, if you will. This is a picture. This is some views of it was like a forest of optical elements. You can see the green pump laser. You can even see the beams in that view. And we use these to do the spectroscopy. So basically take ultrafast lasers and run it through one of these, and allows us to make them tunable. And that's how we do the spectroscopy. Okay, and I think that is the end of the tour. Nate, thank you so much for making that video. It was really fun to see everyone working there, and it's really fun to be a part of this. I see that it's 7:20, and so I think what I'd like to do is I'm just going to share the screen just to kind of close out a couple more things. There we go. So we sort of talked through a number of things that are in these slides. I just want to kind of show the people who are working on them. So we saw Kelsey and Nicole working on the first the photocatalysis project, and we saw John and Yo-Yo working on the organic photovoltaics project. We do a lot of work with Enrique Gomez, who's here in chemical engineering, and on the project funded by the Navy there, the organic photovoltaics. We saw Jianing and Jerry, Yuja as actual name, working on the electrocatalysis project with collaboration with the Ray's group. And then finally we saw Kyle, and that two-dimensional materials group is sort of really aligned with the two-dimensional crystal consortium, or 2DCC, which is on campus. It's a national, it's a national user facility for people to come and grow these novel materials. Every time I talk about what the group does, I am required to make this statement here. And so I have to acknowledge that there is a conflict of interest when we talk about the work. When I talk about it at conferences or publish papers, people become aware that the instrumentation that we use is available for commercial purchase, and so the company benefits from that. And so I just have acknowledged that is a potential conflict of interest. And finally, I'd like to just show some sort of pre-pandemic pictures of the group. This was in our backyard. We were celebrating some people who had recently graduated. This was back in late 2019, this was late 2019. And then this is sort of the lower left is kind of what we look like now. We're all on via Zoom and such. It was just a little snapshot in the middle of a group meeting recently. But anyway, I would be happy to answer any questions or comments any people have about the work or the students. So let me just kind of stop talking, and I'll just open up the chat and just kind of monitor that and see if anybody has anything. Jen, if the participants have questions, can they type it in the chat, or is there another means of communicating? Oh, okay. They should use Q&A. Okay. I'm not really sure what that means. Oh, here's Q&A. Got it. Thanks, Daryl.
John, there's a question in the chat from Laurie about how the funding is going since COVID.
Oh, okay. That's an interesting question. So that's a mixed bag. So some people are doing just fine. Unfortunately, it's sometimes a situation where people who are sort of established, they can kind of keep going because there's not too many questions that have to be asked, but it's sometimes a really difficult time to get started. And I think there's several reasons for that. COVID has made doing things that require working together, like in person, really, really hard. It's been hard to start things, and I think you'll see that in some of the students' comments and in the panel. But I think that the COVID, the funding situation has been fairly stable, at least from in terms of budgets and people who are kind of have gotten some funding established. Um, I see here a question from Carol. How fast are your ultrafast lasers? Um, so the laser pulses themselves are about 10 to the minus 13 seconds long. And just for reference, um, that gives you that's the time required for some atoms in a molecule to kind of vibrate just a few times. It's fast enough to watch bonds break and form in real time. It's even fast enough to watch electrons kind of move from one. They'll make several attempts, but you can actually watch them move from one molecule to another one. Call that electron transfer, of course. And flashback to the 70s, research work on campus. Okay, here's a comment from John Furness. Thank you for sharing your work, lab, and students. Flashback to the 70s, research work on campus that benefited DOE and DOD were often target of protests. What is the atmosphere today? How interesting. Wow. Well, DOE, if we were involved, I don't really encounter that. What I did encounter, I'll tell you, we got some guidance from my program manager in DOE. So it's a solar photochemistry program, and it's kind of meant to deal with like climate change and stuff like that, right? And in the past, prior to the current administration, we couldn't talk about that. So, because you could not get funded if the Trump administration thought that you were, anyway. So our program manager said, look, we all know why we do what we do. You don't need to emphasize it in the proposals for these 4 years, and let's just let's understand one another. I thought that was a really creative way to deal with that.
There's a question from Yuki about accepting undergraduate students into your lab or
I,
engagement of undergrad students in research.
yeah, I do. I have 3 undergraduates right now, and 2 of them are graduating. And so I'm actually looking for new undergraduate students. Yeah. You're welcome, Ryan. Thanks for tuning in. Well, I want to make sure that we have time to hear from our students, kind of how things are going from their perspective in the laboratories. So let me thank you again for just tuning in and giving me the opportunity to kind of tell you about some of the stuff that we have going on in the laboratories in chemistry. And so with that, let me stop sharing. And thanks, Tracy. Tracy Moore was a comment there. So Jen, what's the next?
I think I'm taking over, John. This
Oh, okay. All
Yep.
right. I will disappear so that I won't distract.
Okay. So thank you again for joining us for the Eberly Forum. I'm Andy Santacroce. I'm the president of the Alumni Society Board of the Eberly College of Science. I hope everyone enjoyed the virtual tour of John Asbury's lab. As mentioned earlier, the next part of the Eberly Forum will feature a Q&A with 3 of our outstanding students. They'll tell us about how their experiences in labs have changed during COVID. I have some questions to start us off, but I invite everyone on the call to use the Q&A button to submit any questions that you may have. We'll get to as many as we can in the time we have together. And now please welcome our students, Anjali, Max, and John. Anjali, would you please start us off and introduce yourself?
Of course. Hi, my name is Anjali. I'm an undergraduate finishing up my senior year in biochemistry and molecular biology, and I'm in Tim Yashir's lab in the same department. Well, that's been from that.
Can you hear me all right? Okay. Hey everyone, I'm Max. I'm finishing up my third year here as a graduate student in the PhD program in the physics department. John? John? You there?
Can you hear us, John? Okay. How about we call an audible here, and we'll start going through some of the questions, and we'll start here with Anjali, and then John, when we get to you, you can do the intro as part of your response. Sound good? Okay. So Anjali, can you describe some of the changes that have been implemented in the labs since the pandemic started?
Yeah, of course. So, because of the pandemic, obviously masking has been implemented into all lab spaces. So, mandatory lab masking across university buildings. In my case, there's been strict capacities implemented for a lot of laboratory spaces, so both the open lab space and specific facilities, so like microscopy or cell culture rooms. And because of this, we are all scheduling time to ensure that we don't extend the capacity of the space. So the week ahead of going into lab, I schedule all of my time for the week and then only go into lab during those times so that we're not over. Max, how about you?
Yeah, of course, we have the same thing. There's a really strict limitation on the number of people that can be in the lab at any given time. It's usually just 2 people, and we're usually separated by a big wall also. On top of that, on every corner, every table, there's some hand sanitizer and some 70% IPA always available. And so we, of course, have a strict cleaning regimen. We wipe everything down after we're done using it. And yeah, maybe the only benefit of all of this is that our scheduling has become really, really nice and rigorous. It used to be just a little haphazard who's using the equipment today, but now we figure it out down to the hour, a couple days in advance. And I see John's back.
Yeah, my mic is working. Wouldn't be Zoom if it went wrong. So I'm John Swartzfeger. I'm a 5th year in the chemistry department in John Asbury's lab. I didn't catch the question. I had to leave. I'm sorry. How has it affected working?
It was describe some of the changes that have been implemented in the lab since the pandemic started.
Okay. Thank you. Sorry about that. Yeah, in terms of pretty similar to what Max and Anjali were saying, we have hand sanitizer, IPA stuff kind of sitting around at like strategic locations. So, if you have to wipe a door handle down and stuff like that, wiping down workstations and limiting the number of people in a room, I think is about 2 is probably our biggest, maybe a little more in some of the larger spaces. But even when we get to something like that, typically it's, kind of just one person doing work and one, if they need to be, kind of coming in and out. So it's definitely reduced the number of people actively around and in offices. So it's definitely that. And then again, we're following like a cleaning regimen. So you wipe everything down and wipe door handles, and we're trying to stay conscious of where everyone is and stuff like that.
Great, thanks, John. I think, John, we'll stay with you for the next question surrounding how have the changes that you just described, how has that affected you and your research?
I would say for me, it hasn't been our lab I'm in is a little smaller, and we have enough space where we've all been able to kind of do our work. So it hasn't been too much on the front of not being able to do it. I will say from kind of, I guess, a more senior graduate student, I have to do a lot of ordering of stuff. And so as part of my kind of weekly or, regular orders, I have to make sure I include things like mask, hand sanitizer, and make sure we have that. So it's kind of another thing to just keep track of, and also just be conscious of making sure we have like the supplies, making sure, obviously I'm wearing a mask and stuff when I'm doing things. And just like remembering that, of course, now that we're a year in, it's kind of second nature at this point, but doing stuff like that, and then just, making sure everyone is able to interact still, do things like that. Max, how about you? Anything like that?
Yeah, now that really a protocol and procedure has really been well established at this point, I'd say that things are largely unchanged. I also sort of have the responsibility of making sure all the guidelines are followed and we have all the proper PPE and everything else. In my situation, though, early on, definitely my research was heavily affected. At the start of sort of lockdown and quarantine, I was really just getting my feet wet in the lab. And just for context, my ultimate goal in my position in my group was to replace a senior graduate student as sort of the acting lab manager. And so it was really important in a very small amount of time that I got up to speed. And so not being able to go into the lab for a few months was obviously very difficult. Training on certain equipment was very difficult. But, eventually overcame that and everything worked out once we got things well ordered in the lab. Yeah. What about you, Anjali?
I think I've had a similar experience to both of you. Now, having been in the pandemic a year, I'd say the changes are less evident, but in the beginning, it was definitely a stark change. As an undergraduate, I wasn't allowed into lab until August. So from March to August, I was completely remote. Even now, there's a huge emphasis on working remotely when you can. So a lot of my work has shifted towards the computational and bioinformatics side of things rather than wet lab experiments. And just because we're working with biological systems and cells, since I'm able to come into lab less often because of maintaining capacity, that usually means I do less actual experiments at the bench, and then there's less data, but I'm able to work with that data a bit more. It's just a shift in like where my priorities.
Thanks, Anjali. Just a quick reminder to everybody, listening in on the call here. If you have a question, please use the Q&A area to enter that in, and we'll try and get to as many of those as we can. So, Max, I think we'll start with you for the next one. How have you adapted to keep your productivity up while maintaining social distancing in the lab or in your office?
Yeah, sure. Well, like we mentioned before, scheduling, I think, for all of us has become, really well regimented. And so there's really not too much of an issue of, getting into the lab, getting my samples and really getting the data I need. I also have the luxury of having, full remote access to a lot of the equipment that we use. So things haven't really slowed down that front. Obviously, easy remote access to any of the computers that have any of the software I may need. So really, thankfully, with modern technology, things haven't had to slow down too much, and I've really been able to maintain my productivity, I'd say. What about you, John?
Yeah, I guess I would share the same kind of idea with in the first month or two, obviously we weren't in, so that was kind of more of a low period where not much was getting done in terms of new research. It was kind of just reading and looking at data. But once we got kind of things going, I was kind of, at least for the chemistry department, since I was more senior, was one of the first to be allowed back in. And so it kind of returned to a pretty normal stream of research and working up data and stuff. And like Max, you said, we have a lot of our instruments are connected to computers that we can access, at least the data we can access remotely. So if I'm just doing data, I can do from home and stuff like that. So not too much, I guess, at least for me on experiment end. It has been, since we do collaborate a bit, it has been a bit more difficult to get samples sometimes, or at least it takes a little longer. I know we were getting samples from Stanford and we had to work around kind of their schedule where they were only allowed in certain days on certain hours. And so it was really tricky in the beginning to kind of get samples in. But again, since it's been a while, it's kind of it's kind of worked itself out. So it's a bit easier now. How about you, Anjali?
Yeah, I'd say in terms of keeping up productivity, time management and planning really well has been key. I do a lot of experiments where they'll occur on a specific time course, so making sure that I have everything prepared well ahead of time so that the day that I run the experiment, nothing goes awry, especially since I can't just come in, make media really quickly because of the scheduling. And I think a lot of people in microbiology and biochemistry at least have, and I can speak more towards microbiology, have picked up a lot of additional training and skills in bioinformatics, which again has increased productivity. I think a lot of times this work was maybe given to people with more expertise, but now as we're heading into a year of pandemic, I think everyone in the field now knows a little bit of bioinformatics, which is a big game changer in terms of keeping up productivity and research progress.
Thanks everyone for your thoughts on that. So thank you, Daryl, for our first live question here. And Anjali, maybe we'll start with you on this one. Did any of you find collaboration or communication by Zoom an obstacle or a constraint on your research?
Yes and no. There's definitely aspects of Zoom communication where it's less impromptu sometimes. So if you have a breakthrough or a really big idea, you can't immediately go talk about it with your peers and your mentors and that kind of thing. However, the implementation of Zoom has given me personally, and I'm sure many people in the field, access to a lot more seminars and talks and people than at least I would have traditionally had access to. So I was over the summer able to attend a bunch of remote talks, whereas if everything were in person, they'd be all across the country and globe, and that wouldn't have been possible, and it's only possible through Zoom. So on my end, I think the positives outweighed the negatives.
So either Max or John, anything additional to add to kind of Anjali's experience? You don't have to offer comments specifically if you don't have anything, because we do have another question teed up as well. But just leave that question from Daryl open for one more minute here to see if you guys have any other thoughts on that one.
Yeah, sure. Well, I'm actually part of the 2DCC, the two-dimensional crystal consortium that was mentioned before. And so it's a national user facility and we have a lot of collaborators. And so I was used to using, different platforms for communicating with people from California anyway. So really nothing much has changed on that front. And just +1 to the extra conferences and talks. That's actually been a really, really great aspect of everything.
Yep, I had more or less the same thing in terms of collaborations that weren't on campus, which for what I was working with was actually a bit. It was all kind of already going through, I think, Zoom already. So that transition wasn't too much. On-campus collaboration suffered some because you can't, meet up and stuff. And then the same thing that I was invited or not invited, but, they were sending out emails about like, oh, here's like all these conferences, which, normally might be a bit more I felt like inclusive, kind of, where like, maybe a small set of people would see it and they're like, oh, here, just, whoever wants to come and watch, some experts in the field talk about their research, just have at it. So that's been kind of neat.
Great. So we have a question here from John Furness. Thank you, John, for the question. So there's one question for you, Anjali, and then one for John and Max, for both of you. So the first part is, Anjali, what, if any, impact on your academic progress has this had on your graduation? And then John and Max, just for you to think about while Anjali's answering, what impact on your research work towards dissertation and graduation?
Speaking from my perspective, there was very little impact, if any, on my academic process towards graduation. I was on pretty much the same track from before the pandemic to now being in the pandemic. There hasn't been any limitations in classes that I've been able to take. A lot of the academic labs are still running in some capacity in person, so I was still able to attend those and fulfill those requirements for graduation. This is being said as entering the pandemic as a junior and then now graduating in the middle of this all. So this might be different for younger students, but for me, there wasn't a large impact.
In terms of dissertation research and work on that, as far as I can tell, still kind of on the same track. No major major obstacles or no major kind of dips or anything. Like I said, there was like a month or two again where we weren't in, so there's that kind of dead space. But other than that, I feel like I'm making about the same, or at least within a margin, the same progress I would have been making otherwise.
Yeah, for the overall trajectory of things, I really wasn't too affected. When things started, I was mainly focusing on my comprehensive exam anyway, which would allow me to become, a full-fledged research assistant. So I was supposed to be really doubling down on my reading and everything anyway. So I took that in August, and by that time we had already been, right back into the lab working smoothly.
Okay, thanks everybody. Let's switch to maybe a little bit, away from the lab specifically, and just ask all of you, were there any creative ways that you found to stay connected to family and friends during this time of such isolation? Max, why don't we start with you on this one?
Sure. I probably took the approach that a lot of people did, and my friends and I just immediately started having Friday night Zoom hangouts. Also, I'm secretly really big into video games, but none of my friends in my cohort were here, and so this was like a great way for me to rope them into playing things with me. But nothing too creative, I guess. What about you, Anjali?
I think a lot of the same Zoom hangouts, virtual movie nights, family FaceTimes. I think that's about it. Into August and into September, we did socially distanced picnics over at Hub Lawn just to see people in person, all masked, 10 feet apart. And it was nice. It was one of those, makes you really remember how grateful you are to see people. How about you, John?
Yeah, nothing too crazy on my end. Again, like Max, play a lot of video games, so it was a good excuse to get on line with a couple of my friends from undergrad and get on Discord and just play for a few hours and just talk about what was going on and just kind of like that. Other than that, phone calls with family. Now we've been doing, we've done at least once or twice in lab where we've tried to get everyone together and eat lunch like outside. So just to, again, try and because especially with everything the way it is, it's hard, you don't see everyone like you used to in lab. And so even though I know all these people, it's like I haven't seen you in like, or I haven't talked, I see them, but I don't get to talk to them for like, 5 minutes, 10 minutes, an hour, whatever it used to be. And so now it's like, oh, we're going to go outside, eat lunch, and, return to some level of normalcy.
Great. So I see we have a question from Daryl, but I think I'm going to hold that for just 1 minute because I think that'll be a great kind of wrap-up question for us here. So let me ask one other question. What were some aspects of your student experience that suffered a lot from the isolation? Things like synergy from discussions with peers, starting new collaborations, maybe training on new instruments, those types of things. John, you want to start us off?
Sure. I guess I can think of maybe two that are like the biggest ones for me. The first one was just the more social nature of research. So like in our lab, we have 3 people in an office. We have a couple offices there. And so it'd be very common for us to randomly or just, sporadically start talking about each other's work. Like someone might discover something that they fit some data and figured something out. And we might have like a half an hour discussion, just talking through that. And that was always really nice because it helped get other eyes on it, and it helped you kind of think about things differently. And then just other talks just about stuff in general, we might spend 30 minutes, 40 minutes just talking, research, life, stuff like that. And that was just always really nice. It's just like an impromptu social thing. It kind of kept at least me sane. It was kind of nice to have. The second thing I think for not so much research, but just for the way chemistry works for getting new students in. So getting first years, they come in and then they start looking for labs basically in their first, normally it would be end of fall, but I think they pushed it to spring. And so you'd basically set up rotations where the students could come in and, see how it is to work in the lab and ask questions and stuff. And that I think really suffered because of this, because we're not supposed to have a lot of people. So we had to be a bit more organized, which for our lab, we would typically just, tell them whenever you're free, stop down, say hi, or, and we'd also schedule times. But when you're not supposed to have, a number of people in the lab space, or you're not supposed to have more than one person in the office, which is where they would stay, it's hard to get people in there for more than, an hour or so to, see what's going on and really get to like know them. So I think that's been something that suffered probably quite a bit, which is unfortunate. Max, I'm not sure how it is for you or anything like that.
Yeah, to your first point, I think I have a very similar experience. I work with 2 like really great postdocs, worked, well, still do, but there used to be really great instant feedback on results. We'd see something come up in a scan. I'd say, I don't know what this is. They'd say, turn this knob. I'd turn that knob. Things would work, and now I don't really have that. I have to wait for them to reply in Teams or something. So yeah, synergy and a sense of discussion has definitely fallen off just a little bit. Personally speaking, focus on the isolation point. Things are definitely more lonely around here. Right now I'm sitting in this really big office, and I've been the only soul in here for over a year now. And it used to be full of all my friends who I'm really close with from my cohort. But they're all computational and theoretical physicists, so they just stay home all day now. So I'm the only one around. So yeah, there have definitely been a lot of challenges from the isolation, I'd say. Yeah.
Yeah, and I'll just jump off there and touch on a few things. I think the synergy and discussion definitely has fallen off. My lab is right next to this huge conference room that a couple of the other labs on the floor use, as well as ours. And there was always just a buzz in there of like discussing results and discussing data and discussing various things to do with the field. And I will say some of my greatest breakthroughs and some really good mentorship and career advice have happened in that conference room. And now it's a capacity of one, which has kind of put a damper on things. In terms of training, ahead of the pandemic, I was 2/3 of the way done with training on a confocal microscope, and then pandemic happened, and I just now finished training a year later. So that's where there's definitely a little bit of suffering in terms of training. Like I mentioned earlier, there's less time in labs, so there's less time to do experiments at the bench. And then I think from student experience, from the undergraduate perspective, I'm sure all of you are aware of like how many experiences were like valuable for you at that point. And so there's a lot of things like that, like Penn State football was canceled this year, blue and white game was canceled this year, all those aspects from the social experience of being an undergraduate at Penn State that have definitely lost, and just some of those friendships that you make from that have definitely suffered a little bit since you're not seeing people. But overall, still hanging in there.
Okay, thanks a lot. And as promised, we're going to use Daryl's question as the last one to round us out. What are each of your plans after graduation? I guess Anjali, we'll start with you on this one.
Yeah, I'm planning on attending graduate school. If any of you are familiar with the graduate school application process, I went through interviews entirely remote from this room that I'm sitting in right now. So I'm headed to graduate school in California to study microbial biology. How about you, Max?
I guess things are a little more up in the air for me right now. I'm just really getting into the motion of the research here, and have to still get some papers out and everything. But I like academia. I could see myself in a national lab or something, but I'm not really sure yet. I just have to see how much I like everything.
Yeah, for me, I'm not sure I like the problem solving aspect of research, definitely. I definitely like helping people figure things out. I don't know if I'd want to go into research as a permanent job, but I definitely like the idea of helping people figure things out, as they come up, or making sure instruments work, stuff like that. And I could also see myself doing academia, but not from a research standpoint, more of just educational, teaching along those lines. I've gotten some experience with that, and I have enjoyed being able to interact with the students and help them learn things. So.
Great, thanks, and certainly best of luck to you all, whatever those plans may be. I really want to take an opportunity now, just as we're wrapping up our forum, to thank everyone for attending the forum. Also to thank John Asbury for the virtual tour of the lab. Also to thank Anjali, Max, and John, and really to applaud the three of you for being able to navigate in such a difficult time that we've had, and still, remain as positive and, optimistic of everything as you have through, and we can tell through your answers. So thanks so much there. And, thank you, of course, to Dean Lankilde and Jennifer for being able to put together and support this session. Hopefully everyone, again, enjoyed it, and look forward to seeing you at another one of these sometime soon. Dean Lankilde, anything else to add before we close out?
That's fantastic. Thank you. I hope you all enjoyed this and found it as informative as I did. Thank you, John, for a great tour, and thank you so much, students, for your insight into what life has been like.
Yeah, thank you so much, students. Really appreciate your input.